Atomic structure. In order to understand atomic structure, we must start with a definition of matter. Matter refers to the physical substances that we experience through our senses. Most matter can be felt and seen. Some types of matter have odor or taste, and some can be heard. Our senses can distinguish matter because it has physical and chemical properties. Chemical properties describe how these substances react to form other substances. Physical properties describe boiling points, specific weights, and so on. If we divide a substance into smaller and smaller quantities, we can still measure the same chemical and physical properties. At some point, this is no longer true when we no longer have the original substance. The smallest particle of a substance that retains the chemical and physical properties of the substance is called a molecule. When we divide the molecule further, we now are dealing with its basic components. Careful investigation of the chemical and physical properties of matter indicates that all naturally occurring matter is made up of over 100 basic chemical substances known as elements. Each element has different chemical and physical properties. Elements are familiar to all of us as either metals such as iron, aluminum, zinc, lead, copper, tin, and mercury, or nonmetals such as carbon, sulfur, phosphorus, iodine, oxygen, hydrogen, and nitrogen. Each of these elements has a symbol composed of letters taken from the name, sometimes the Latin or German name of the element. For example, hydrogen is represented by H, oxygen by O, iron by Fe, uranium by U. A list of the elements known to us is in the chart of the nuclides. The chart lists different properties of the elements that we will discuss later. If we divide an amount of a pure element into smaller and smaller parts, a point is reached at which the element no longer retains its properties. The smallest particle of an element that does retain properties of that element is an atom. Each of the elements has a characteristic mass. This is usually called the atomic weight of the element. The atomic weight is the mass of the average atom of the element found in nature and is normally given in AMUs or atomic mass units. Individual atoms chemically combine to form molecules. To further clarify the definitions of atom, molecule, and element, consider a molecule of water. Water is not an element because it consists of different kinds of atoms. It consists of one atom of oxygen and two atoms of hydrogen. The molecule cannot be divided and still retains the properties of water. Hence, this particle is a molecule. The one atom of oxygen cannot be divided and still retain the properties of oxygen. It is an atom of oxygen. Consider the atom of uranium. It is also a molecule of uranium because it cannot be divided and still retain the properties of uranium. But what is an atom? The original picture of the atom was made up by Niels Bohr, a Danish physicist. He pictured the atom as having two parts, a dense, small, central positively charged core surrounded by a light and rather large negatively charged cloud of electrons. The core of the atom he called the nucleus and compared it to the sun. This core or nucleus is made up of two fundamental particles, protons with positive charges and neutrons with no charge. Each electron in the cloud around the nucleus has a negative charge and orbits the nucleus like the planets move around the sun. The attraction between the positive and negative charges holds the electron cloud around the nucleus. This type of force, attraction or repulsion between different or similar charges, is called an electrostatic force. A counterbalancing centrifugal force caused by the electron orbiting the nucleus prevents it from being attracted to the nucleus. The most important properties of these particles that make up the atom are indicated in this table. From this table, you can see that the masses of the proton and neutron are approximately equal, the neutron having a little more mass. However, both the proton and neutron have a much greater mass than the electron. The entire atom is about 10 to the -8th centimeter in diameter, while the nucleus is about 10 to the negative 12th centimeter in diameter. This means that 100 million atoms could fit in a 1 centimeter line, a line with a length about this long. A comparison of the diameter of the atom and the diameter of the nucleus shows that the nucleus occupies only a small part of the atom's volume. The diameter of the atom is about 10,000 times that of the nucleus, yet more than 99.9% of an atom's mass is in the small nucleus. An analogy may help you to visualize the relative sizes of the atomic particles and the spaces between them. The simplest atom is the hydrogen atom, which contains 1 proton, 1 electron, and no neutrons. Let the nucleus of the hydrogen atom be represented by a common marble. The electron's orbit could then be represented by a sphere located 1,610 kilometers or 1,000 miles from the marble.